So if you've ever been on the planning side for a large facility, maybe a campus, a stadium, even a big hotel, you know the pain point.
Oh yeah, the cabling nightmare.
Exactly. You're trying to push multiple signals, especially something like satellite TV, over long distances, and you just can't. You end up with this massive, expensive bundle of copper coax.
And that's really where we're focusing today. We're looking at what a unit like the Thor BroadcastF-SattGalaxy-TX RX-5 really does. Its whole job is consolidation.
Okay, so consolidation of what exactly?
It takes 5 separate RF signals. So you've got 4 feeds from your satellite LNBs, and then a 5th for your terrestrial stuff, like off-air TV or radio.
That sounds complex already. But for anyone who doesn't live in this world, those 4 LNB feeds, that's not just 4 cables, is it?
No, not at all. That's the key. To get all the polarizations, vertical high, horizontal low, and so on, you're actually looking at 8 separate coax lines for the satellite alone.
8 lines, plus the terrestrial one.
So 9. You're trying to run 9 bulky copper trunk lines.
And here's the part that it blows my mind. This technology replaces all 9 of those potential copper runs with one single-mode optical cable.
One. That's it. It instantly solves the distance and the congestion problem.
The logistics of that alone must be phenomenal.
It is. You're using light, so that standard signal loss you get with copper, the attenuation, it's just not a problem anymore. It's perfect for those long RF runs where coax would just completely fail.
And you don't even have to mount the transmitter right at the dish, I imagine.
Exactly. The fiber gives you so much flexibility in the physical install.
Okay, logistics make sense. But how do you actually cram 5 high bandwidth signals into one tiny strand of glass without them all just interfering with each other? What's the secret sauce there?
Well, the secret is something called wavelength division multiplexing, CWDM for short.
Okay.
Think of it this way. Instead of sending 5 trucks down one highway lane, we're giving each truck its own lane painted in a different color of light.
So each signal gets its own unique color, its own wavelength.
Precisely. They're totally distinct. The system uses 1510 nanometers for one satellite band, 1530 for the next, 1550, 1570, all the way to 1590 for the terrestrial signal.
And because they're separate light frequencies, there's no crosstalk.
0. The signals stay completely isolated, which is critical when you're going 10 kilometers.
Speaking of distance, signal integrity has to be a huge concern. Even with fiber, how does the system keep that signal stable and clean over such a long run?
Right, and that comes down to some really smart engineering. 2 things, really. First, it has built-in automatic gain control, or AGC.
Which just keeps the power level steady.
Exactly. It smooths out any minor fluctuations from the input. And second, and this is crucial, it uses what are called SEEPC connectors.
Angle polish.
Yes. That specific 8-degree angle on the polish physically stops light from reflecting back down the fiber. It eliminates back reflections, which would just introduce noise and corrupt the signal.
So where does this really get used? What's the killer application?
It's an excellent solution for MDU distribution.
MDU. Multi-dwelling units. So apartment complexes, hospitals, places like that.
You got it. It's perfect for L-band distribution in those kinds of environments.
And the reach for you, the person designing this network, this is the compelling part. One single transmitter has enough power to feed up to 32 optical receivers.
And those receivers can be anywhere within a 10-kilometer radius. It's a huge footprint from that one starting point.
A 10-kilometer radius. Wow.
And that's not even the end of it. The scale just explodes from there. Each of those 32 receivers turns the light back into the 5 original RF feeds.
So they become their own local distribution points.
Right. From there, they can feed multi-switches, and suddenly the total number of outlets of subscribers can easily go over 1,000.
All from that one initial fiber line.
All from that one fiber. It's built for those point-to multi-point systems.
So to sum it up, 5 complex signals, 1 fiber, a 10-kilometer radius. The efficiency gain compared to old-school coax is just staggering.
It is.
Yeah.
While we focus on that efficiency, here's a thought.
Yeah.
What are the bigger implications, maybe from a security or redundancy standpoint, when you consolidate so many critical signals, global satellite news, local emergency TV into one single high-capacity physical point? The efficiency is undeniable, but that centralization, it changes the game entirely, doesn't it?